Welcome to Chapter 2, Correlation Analysis. In this chapter, students will be able to 1. Build a scatter plot and interpret. 2. Calculate the values of correlation coefficient R and coefficient of determination R square. 3. Perform a correlation analysis interpreting the strength and direction of relationships between variables. 4. Use statistical software, namely SPSS, to run the correlation analysis. Relationships between variables can be assessed using a linear regression model developed based on the existence of relationships between dependent and independent variables. It's prior to examine the relationship between these two variables. In other words, it is a statistical technique that used to investigate the relationship between two variables that can be examined through graphical method, scatter plot, and numerical method, non-graphical method, correlation analysis, Pearson's correlation coefficient. Using the first method, which is scatter diagram. A scatter diagram is a diagram of the values of y versus the corresponding values of x, where the y will be the vertical axis while x will be the horizontal axis. The uses of scatter diagram are to determine if there is a linear relationship between the dependent variable and independent variable, the type of relationship, strength, and the existence of outlier. These are the types of scatter diagrams. And next, the graphs showed the strength and direction of relationships between the variables. In addition, the interpretation of scatter diagram will depend on either the plots are rising upwards to the right, as x increases, y also increases, or vice versa. Besides, for the strength of relationships, if the plots are far apart, the relationship will be weak, while if it is closer to the plots, the strength of relationships will be stronger. By using the numerical method, we will have to explore more on the correlation. The correlation coefficient measures the strength of the linear relationship between the dependent and independent variable. Value of correlation coefficient is between -1.0 and 1.0. These are the examples of types of correlation with its value of coefficients, such as perfect negative correlation with R equals to -1.0 and strong negative correlation with R equals to -0.85. Besides, the purpose of correlation analysis is to make predictions about one variable based on what we know about another variable. Additionally, the value of correlation coefficient can be calculated using the following formula. The strength and direction of correlation can be identified using the following scale. These are the examples for the interpretations of correlation coefficient value, R. Lastly, in order to validate the value, hypothesis testing for one-tailed test and two-tailed test need to be applied, and the procedure are as follows.